Guys, we want to see another problem of center of gravity. So we're told to make a neat sketch of the graph of y equal to e to the power x. Then show the strip that we will use to calculate the volume generated. If the area bounded by that graph, the lines x equal to 0, y equal to 0, and x equal to 2 rotate about the x-axis. Then after that, we'll calculate our volume, and then we'll calculate the volume moment about the x-axis, as well as the distance of center of gravity from the x-axis. So let's go to the A part. You see that in the A part, I've taken my time to pick out all the important information. So my graphs are y equal to e to the power x. Then I get y equal to 0, x equal to 0, x equal to 2. Then there's another piece of information which says x-axis rotation. The importance of this one is that it tells us how our formula for volume is cut. So looking at that information, you see I've got 4 graphs. Whenever I've got 4 graphs, I must remember that 2 are my limit, and I'm picking these 2 because you must read your limits from the same axis, being the x-axis, and if you read limits from the x, it means your strip must also touch the x-axis. Then we must not forget that another name for y equal to 0 is the x-axis, and another name for x equal to 0 is the y-axis. So we can now sketch our graphs. So immediately I put the x and y-axis. I'm done with 2 graphs already from what we have seen up there, because y equal to 0, x equal to 0, our x and y plane. So the next easy graph is x equal to 2. I just need to put it anywhere on the x-axis, because x equal to 2 means it touches the x-axis only at 2. So if I put my 2 there, then this is my x equal to 2. So the last graph is the exponential graph. Usually students struggle to know whether does it move in this manner or does it move in this manner. So if you are not so sure, the limit can always guide you. So I will start by using 0 into the equation. That will be my lower limit, and you see when you put 0, it means you are on the y-axis. So if I put 0 there, I will be getting y equal to e to the power 0, and that's 1, which means whenever I'm on the y-axis, I should be having, on the y-axis, I should be having 1 there. Now, the next thing is to put the upper limit. So the purpose of the upper limit is just to see whether when I substitute it there, is my answer smaller than 1 or is it bigger than 1? If it is smaller than 1, then my graph will be going this way. If it is bigger than 1, then my graph will be going that way, because at 2 I should be somewhere. So that is it. So if I put x equal to 2 there, I should be having y equal to e to the power 2, which is obviously a number bigger than 1. So if we say our e to the power 2 is somewhere up there, then you see that at x equal to 2, we should be here. So it gives us a knowledge of how the graph should look like. So my exponential graph should be something of this nature, touching the y-axis at 1. So the region I'm shading should be surrounded by my 4 graphs. So that is the portion that must be shaded. So if you already have an idea about your limit, you see that each time you read limit on the x, that is where your strip must go. So when you're looking at it, the strip that goes to the x-axis should be the vertical one. Or if you want to also try other options, if you want to try a horizontal strip, you see that the fact that the strip is not touching the same 2 graphs all the time show that horizontal is not right, but vertical will always touch the same 2 graphs all the times. So this is how I can pick the right strip for my shaded portion. The strip should forever touch the same 2 graphs. Whether you put it towards the left or towards the right or at the center, you see the same 2 graphs. So that strip is touching the x-axis. Then my strip is vertical. What it reminds me is that the 2 graphs it's touching, the one at the top and the one at the bottom, must be labeled using the y-axis. So the one at the top will be a first graph, which corresponds to the exponential. The one at the bottom is the x-axis. Another name for the x-axis is y equal to 0. So that's your second graph. So there, I'm done with my graphs. I've shaded every portion with the portion surrounded by the 4 graphs. So I can then do the B part, which requires us to get the volume. So if I'm calculating the volume, one important thing is the axis of rotation. It tells me how my volume starts, as you saw me put it there. So I know that my volume must start with Vx. Then, how does it end? I go to my graph, I look at my strip. My strip tells me how my volume ends. So my volume ends with a dx. So as an N6 student, you simply go to page 5 of your formula sheet. You search for that formula that starts with Vx and ends with dx. It's there on page 5. So you get y1 squared minus y2 squared dx. Then you can now start substituting your limit. Your a and b, we saw it already over there, is 0 to 2. Or if you are looking at the x-axis, it's from 0 to 2. y1 is simply e to the power x, y2 is a 0. It makes life easy. So when you integrate, no, you are squaring it, sorry. If you square y1, it becomes e to the power 2x, since you are squaring e to the power x. It's the same thing as multiplying it by itself when you are squaring something where you add the powers. So if we integrate this, we'll get e to the power 2x over 2 from 0 to 2. Then we'll put our limit. We'll get e to the power 4. If you put 2 there, 2 times 2 is a 4 over 2. Then the lower limit, we'll get e to the power 0 over 2. So we can now consult with our calculator to see what does that give us. So I will take e to the power 4 on 2, that's what we have, minus e to the power 0. E to the power 0 is just a 1 over 2. Once I get my answer, I multiply that by pi. Since pi is common, sorry, I think I've made a mistake. And then e to the power 4 on 2 minus 1 over 2. That is e to the power 4 on 2 minus 1 over 2. That is what I get. Then I multiply this by pi. That gives me 84. My volume is 84,192 unit cube. That's the unit for volume. So for volume, I'm done. Then you can go to the last part of the problem. It says calculate the volume moment about the x-axis as well as distance of center of gravity from the x-axis. So that definition is again on page 5 of the N6 formula sheet. The volume moment about the x-axis on page 5 is defined as RdA. So we are supposed to develop this RdV, sorry, this volume moment, not area moment. We are supposed to develop that formula using your graph. When I start that, I will start by making sure I replace dV by the formula for my volume. So that is the easy part to do. So I will get pi, the integral from a to b. I will leave space for my r. Then I capture y1 squared minus y2 squared dx. Then for my r, I must define it with the help of that x-axis there. So to do that definition, I go back to my graph. I start from the center of my strip. I move to the x-axis. So that is my graph, center of my strip. I move to the x-axis. So you can see the blue line, dotted line there, it's a vertical movement. Each time you use a vertical movement, we're supposed to use y to represent r. But if your strip is also in the same direction as the vertical movement, we always settle for r being the average of the two graphs that your strip is touching. You see your strip is touching y1 above it, y2 below it. And the reason why we do that is because the strip is supposed to just be a very thin line with y1 at the top, y2 at the bottom. Then r is the coordinate of the midpoint, and that's where they're coming from with that one. So our r is y1 plus y2 over 2. This looks like a complicated calculation. We'll take 2 out, but what will make it easy is the fact that from our graph, as you can see, y2 is 0. So if you replace every y2 there by 0, you'll be left with y1 cubed dx, because y2 is 0. Then y1 is simply e to the power x. So if you take e to the power x cubed, that means you are taking e to the power x times e to the power x times e to the power x, which gives us e to the power 3x. So that's what we are left with. So we have pi over 2, the integral from a and b at the same 0 and 2, e to the power 3x dx, which if we integrate, we'll get e to the power 3x over 3. From 0 to 2, we put our limit, starting with the upper limit, which is 2. 2 times 3 is 6. We get e to the power 6 over 3, minus the lower limit is a 0. E to the power 0, it's obviously 1 over 3. Then if we go to our calculator, we'll see what is our volume moment. So to get our volume moment, we'll take e to the power 6 on 3 minus 1 on 3, since e to the power 0 is 1. That will give us 134. Then we'll multiply that by pi on 2. Sorry, I think I've made a mistake again. E to the power 6 on 3 minus 1 on 3, 134. Then I'll multiply that by my pi on 2. I'll say pi on 2 is common. So that should give me 210, 711. So I get 210,711 unit to the power 4. You see, volume moment is volume times distance, so that's why we're taking unit to the power 4. Then we can now get the distance, the center of gravity from the x-axis. That's another way of defining the y-ordinate of the center of gravity, which is volume moment over x over the volume. Our volume moment is 210,711. Our volume was 84,192. If we do this division by 84,192, we'll get 2,503 units. So usually when you calculate coordinate of center of gravity, you should be able to check from your graph whether your answer makes sense. If you go back to the graph, you can see that our shaded portion lies between 0 and e squared. To be sure about it, you need to check what is the meaning of e squared. E squared is actually 7,389. So if this is the same thing as 7,389, then your center of gravity is at 2,5. You see, it makes sense because you are looking for the y-ordinate of the shaded portion there. So your answer must be within the diagram between 0 to 7,389. So guys, thank you very much. That's how we get our center of gravity.